So one of the things that you have to pay attention to when you're on a boat, which is different from if you're building a battery system for, say, a home or a cabin. I guess maybe not for a cabin. Anyways, it is that it's entirely possible that you could go weeks or months away from the boat. And during that time, you might have solar, and your solar might be able to keep things topped up. But let's say you have to take the solar down because you're storing it for the winter. In any case, you can go periods of time where the system is left alone, for whatever reason you can imagine. During that time, the batteries can start to drain. Again, it'd be nice if you had solar panels that kept everything topped up, but it's not always the case. So at the end of 2 videos ago, when I tried to top this up to get ready for the discharge test, I was really shocked by how bad the parasitic drain was on these BMSes. And I got to thinking, I am in a very kind of rare and cool situation where I have effectively 6 identical packs where all the cells were matched, built, tested, and shipped at the same time. They've all been kept at the same state of charge. They've all been cycled exactly the same. So it got me thinking. A lot of you lovely people were like, hey, didn't you see? Andy said to set the balance voltage to 3.4 volts before balance would kick in, because balance is quite inefficient, and if it's allowed to run from 3 volts and up, basically the full discharge curve of the battery is going to be balancing when it really doesn't do you any good. Okay, cool. Andy knows his shit. I'm gonna bet that 3.4 is the right number, but I want to test. So what I'm gonna try doing is, let me show you this. I have brought all 6 of the packs back up to 100%. I let it sit at 100% for about 2 days with the default configuration of 3 volts for the balance current, meaning they've all been allowed to balance the last 2 days. So given the fact that we had already balanced it just recently, including a manual top balance, I'm pretty confident in saying these things are as charged as they're going to possibly get. With that, let me start a screen record. I am going to leave pack A at 3.0 as it's shipped by JK. I'm going to set battery B to 3.1. That's higher than the batteries are at most of their curve, so I expect that one to be very close to battery A. Worst internal parasitic loads possible. I'm going to set battery C to 3.2. That should be pretty close to the middle of the curve. So I expect to see less parasitic load if the major parasitic load is the balancing. Battery D is going to be set to 3.3, and battery E is going to be set to the recommended 3.4. On battery F, I'm going to turn off balancing entirely. This is the key thing I want to test in this video. If balancing is pretty damn good, is there an argument to be made where you build a battery, leave balancing on whatever voltage, probably 3.4, to let them all top balance, and then just turn off balancing entirely? Yes, it'll drift out over time, but if you ever notice the deviation getting too bad, just turn on balancing until it's topped out again and then turn it off. I'm really curious to see if there is a noticeable difference between 3.4 all the time and turning off balancing entirely. Now, once I actually set these, I am going to disconnect all of the batteries at their switches, so there's going to be no power going back and forth between them. They'll each be isolated. That also means it's going to shut down the system. And it's going to stay that way for probably close to 2 to 3 weeks. So that's going to be a good period of time. For record, it is now 8:15 on December 16th. I'll tell you what the date is when I come back and actually charge these up. And I will charge them up one at a time to see how much power they take to bring them all the way up. I'm kind of actually really excited about this. It's probably the nerdiest test I've done, and I think it might be the only test like it out there for the few people who actually care about this level of testing of the batteries. Anyways, let's start configuring. Let's go into the BMS app. Now that I'm recording, all of the alerts are happening. I'm gonna go to BMS A, go into settings, go into advanced setting, start balance is 3.0, and we are going to leave that for pack A. So we're done, right? It's not gonna connect unless I do a scan first. And now I've lost battery B because I tried to connect to it before I did a scan. Oh, JK. I can't even reliably get the damn thing to turn off or turn on. It's not turning on. There it goes. Oh, okay, well, while I'm waiting for this one to go into disconnect, let me turn off battery A. So battery A is now isolated, and I'm also going to disconnect the screens. Okay, what happened to the scan app? Why is the button... Oh my god, JK. Okay, and it's in disconnect. Settings. Okay. Start balance is going to be set to 3.1. Okay. And now I'm going to disconnect it. It is disconnected. And the screen is unplugged. Its test has begun. Battery C is going to be 3.2 volts. Okay, setting it to 3.2. It is done, and it is now going to be disconnected from the bus. So 3.0, 3.1, 3.2, D is going to be 3.3. Start balance is 3.3. I'm now going to disconnect it and unplug the screen. Okay, battery E. This is going to get the 3.4 that everyone was recommending. And that's it. So this one gets disconnected. Now, the buck converter is still going to be energized through this test, but that's the same on all of them. So it won't make, whatever difference it makes will be consistent. Okay, so now I am going to go into battery F. I'm going to set this to 3.5 just to help make sure it doesn't come on. But I'm also going to then go into controls and actually turn it off. I'm going to set this to 3.5. I'm going to say OK. I'm going to go to controls, and I'm going to turn off balance. That battery's off. That is disconnected. So now we wait. Let the games begin. So for you, it was a brief instant. For me, it's the other side of the holidays and 3 weeks later. First, whatever holiday you happen to celebrate, happy that holiday. I hope everyone got to spend time with family. I did. Went to frigid Alberta, where I got to be minus 32 Celsius. That was a lot of fun. Good practice for when I'm in the Arctic on the boat. So after I finished filming and went on vacation, I realized I really wish I had have done my numbers slightly differently so that I could have had one of the 6 packs disconnected from the BMS. That would have given me a baseline of how much the BMS itself draws over time. The next video is going to be starting on the 12 volt. I may actually steal some of the parts off of a couple of these batteries and try to repeat the same 3-week period or more, do the math to figure out how it balances, where I have a bank with no BMS on it whatsoever. But that won't be in this video, obviously, because I don't want to have to wait another 3 weeks before this finally gets out. So right now, all the batteries are off, meaning the Quattro and the Servo are also off. My current plan to measure how much power is needed to charge up each battery is going to be, I'm going to connect one at a time, I'm going to go into the configuration and reset it, and then I'm going to turn on the inverter charger and see what it takes to top out the battery. Once that's done, I will disconnect that battery, connect the next battery, and so on. So for me, I've got a fair bit of work. For you, this should be fairly rapid cuts. Okay, so you can't see that, well you can because screen capture, but it's not seeing anything. Of course, everything's powered off. I can turn on the inverter charger first, and that'll bring the system online. Do I need to run the okay. So this is something I've not done before. All of the batteries are disconnected, meaning this is completely down and discharged. If I power it up from the mains, that's going to power up the inverter's capacitors, meaning I can leave the battery disconnected. Well, none of my okay, I'm trying to think now. I think because I've got this plugged into mains, shore power, I'm going to turn this on, and that should charge the capacitors. It's saying low battery, but that makes sense. The batteries are completely disconnected. Will this actually provide any output at all? Whoa! The answer to that was yes, the lights all just flickered. Is the servo going to boot? Yes, the servo's booting out. Okay, and we see the smart shunt already. Okay, so let's go into history. We saw that we drew 1680 amp hours. That just still tickles me pink. Reset. Okay, so we have reset the smart shunt's history. I want to start with the rightmost battery, which had balancing completely disabled. This should, in theory, be the one that requires the lowest amount of charge. And in fact, actually, I was saying before about how... Oh no, because I still don't know what the internal discharge is. Well, still, this is going to tell me what the parasitic draw was of the BMS by itself, nothing on, but a certain amount of that parasitic draw is going to be the internal self-discharge of the batteries. That's what I still need to figure out in a future video. Plug this in. So it's showing currently 3% lost. I know you can't really see this, but it's showing 97% state of charge, 53.31 volts. Let me bring you in closer so you can see what I'm doing. So the first thing is I am connecting battery F. Battery F is now connected. The bus bars are energized. Let's go to the servo. It's showing the battery as 100% state of charge. Wait, where is it getting the... That's off. Oh, the bus is charged up because this is putting power out. That's where the voltage is coming from. At least I think that is. It's showing currently 58.9 volts, but that's got to be because it's trying to charge. It's good, well, it's set to absorption, so it's just putting power onto the bus. So I'm certain these are charged, but just the same. 1, 2, 3, 4, 5, 6. Turn that on. And we are charging. Yeah, we're charging at 1700 watts into one battery. Can you see this? I don't know if you can see that, but it's charging at 31.1 amps, and it's currently 50... Oh, balls. Let me just get the camera in closer. So it's currently charging at 31.9 amps, sitting at 54 volts. I don't know how often the history is going to update. It is going through the shunt. It has to be, because yoink, to the shunt, out to the bus bar. Because it's charging at, well, I was going to say, because it's charging at 30 amps, it might shut off a little bit early, but really, 32 amps is nothing for a 280 amp hour battery. That's like point what C, because I can't do math in my head. Oh, there it is, it's updating. Charge energy, 0.1 kilowatt hours. I'm going to turn off the camera and wait for this to charge and report back. Alright, so it is saying that we charged with 0.3 kilowatt hours. I was kind of hoping for a little more accuracy than that, but there we go. I probably could have done better if I had have gone into the BMS and checked the amp hour rating beforehand. Did I mention I'm not a scientist? Not even close. Turned off battery F, so now the bus is only energized from this. Before I move on, let's take a look at battery E. It is also showing 97%. Reset the history. Let's actually update the firmware because it's being annoying. Hopefully this doesn't actually throw off the accuracy of the charge rate. Wait for the smart shunt to reboot. So now it's updated. This was the one that was set to 3.4 volts. So let's charge. Here we go. 16, 31, 30, 31 amps. Back in another minute. I just heard a pop. Alright, let me start a screen record. Whoa! Fuck! Fuck, 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 fuck! Whoa, 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 I've got big sparks. Shit! I need to cut that. Cutters. I have a fire. I don't know if you saw any of that, but I just had a fire. Ow! 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 Okay, these screens are done. I'm getting rid of these screens. All of them. This is why I never leave anything connected when I am not here and not within earshot. Alright, I am cutting the rest of these screens off. I'm done with these screens. I can't use them. I don't know if you can see that, but there's the scorch mark. And you can see the sooting on the wires. Well, those screens were a waste of money. So was all my time building the buck converters. Alright, I was already not really in the best headspace before I started this video. I really wanted to get it going because it's been so long since I had a video. Because it's been so long since I've had a video up, but I mean, I almost burned. I literally almost had a fire. If I'd been in the bathroom, I wouldn't have caught that. I need to just regroup, clear my head. I am going to turn off the camera, pull out all the buck converters, get rid of the screens, and I'll decide what to do tomorrow. Alright, I've had a few minutes to gather my thoughts. I realized that for this test to be valuable, I need to turn off all the BMSes, otherwise I'm going to have another night of the cells I haven't charged discharging. All the BMSes are off except for BMS F, which I put myself into a situation. I knew better. I knew I should have had fuses. I knew I shouldn't have just said, oh, well, these aren't going to the boat, so it's okay for now. I had to cut the circuit with a fucking chisel and hammer because I didn't even have an edge cutter nearby. I've screwed up a lot on this channel. I think this was my biggest. Alright. Wallowing does no good. I'm going to finish disconnecting the rest of the screens. I'm leaving the cables because it's the only way to turn these fucking BMSs on and off. Pardon my language. I'm pissed off that I had to do this. I screwed up. I don't want to make it sound like I'm blaming JK BMS. I knew better. Period. With that set aside, the fact that they keep selling these fucking parts that aren't compatible with each other. Oh, well, you should have known better. No, I'm sorry. What kind of business is that? I should never have had to make these damn things in the first place. Alright, well, get these off. In a series of fuck-ups, the only thing I did right was not running this stuff when I wasn't here. If I hadn't been home, that would have been the end of my house. It would have been the end of my cats. It would have been the end of everything. And I knew better. I don't know if you know or not, but I try to keep this channel fairly positive and encouraging. I try to show that mistakes happen. I try not to hide my mistakes. And one of the side effects for that is I get a lot of people posting. You probably don't see them because I generally delete them. Basically saying I'm a fucking idiot. I have people tell me that I'm going to screw up and burn everything down. Usually they're talking about the cardboard or something other nonsensical. The hardest part about a project like this is the gaslighting. You have a lot of people tell you you can't do it. And then you make a mistake and your brain wants to tell you, see, they were right. You can't do it. Who are you to think that you could have done this? I think one of the hardest things about taking on a new project, a project really pretty big and complex, is it's one thing to make a mistake because you didn't know better. Those are relatively easy to recover from. The mistakes you make when you should have known better, those are the ones that really stick in your craw. Those are the ones that make you think, yep, I'm not cut out for this. Thankfully, I'm arrogant and naive enough that I ain't gonna stop. But damn if this one isn't a kick in the teeth.
I'll talk to Andrew, try to figure out what I did wrong. There's still lessons to be learned. The worst mistake you can make is screwing up and not learning from it. Also, I should mention, when I restarted the camera, I did my usual push on the cables to make sure the audio cables were in, and there was a push on the cable, so there's a chance, I don't know this yet, you'll know by now, that I didn't even get proper audio. I'm probably going to keep going tonight. I'm not going to be able to sleep if I'm sitting here wondering if I've destroyed my multi-plus, or if I've destroyed my quattro. Yeet. I'm both glad you can't smell what it smells like in here, and wish you could smell what it smells like in here. This isn't your usual, the smoke got out smell. There's something about whatever blew up that's pretty rancid and actually giving me a headache. Turning off this battery and turning off the BMS. Whoa! I don't know what happened, but those cables just jumped. Like there was a big magnetic field in them. That's off. Oh, this battery's on now. That was off already. Wow. This isn't a low point. Anybody want some cheap screens? What I think happened was, when the buck converter exploded, after cutting that wire, I pulled out the quattro from the wall. At that point, I turned off this battery. I think I turned off this battery. At some point, the battery got turned off, meaning the capacitors in the inverter would have discharged. I thought that was still on. I don't know why I thought that. My head's not clear. I turned it on thinking I was turning it off. These capacitors were completely discharged. That was in the on state. It's not now, but it was. So when I turned this output on, it dumped all of the power it could trying to charge up those capacitors, and that amount of current in those coil of wires caused a magnetic field, which is why they jumped. Science. Let's try to turn things back on and see if I can finish charging up battery E, assuming I haven't destroyed everything. No devices found. The first thing I'm going to do is connect just the quattro. That's off. Alright, I know the camera's set back. I've got the screen recorder going. Okay, it says low battery. That's a good sign. At least this thing should still boot up. Okay, that just connected. Is the servo still alive? Servo's coming up. I see the smart shunt. Out of curiosity, how much power did we put into it before it blew up? 0.3 kilowatt hours. Okay, I've got to turn the BMS back on. So hopefully it turns back on. It's not turning back on. I may have fried the BMS. Just out of curiosity, BMS D comes right on. BMS D is off. Alright. Did I just damage this cable? Nope. I destroyed the BMS. Whatever shorted out, it... Oh! I had literally just given up on it, and it booted. The fuck? There it is. Okay. I will know in editing. I don't know right now. It is showing that there's 221.2 amp hours remaining. I believe the number was higher than that before. Okay, let's turn on the battery. Battery is on. I'm watching the screen up here. Oh, you can sort of see it. I doubt it'll come through. But 4, 5, contact. It is charging 32 amps. Ladies, gents, and others, the game's back on. Pumping 2 kilowatts into the battery. It says that it's putting 1700 watts into the battery, so I'm losing 200 watts, 300 watts to conversion. Okay, I'm gonna sit right here while this charges back up, but I'm not gonna make you wait. Okay, that didn't take long. I mean, really didn't take long. Now it's showing 280 amp hours remaining capacity, 0.4 kilowatt hours. I wonder if it finished charging initially, and when it was turning off the when it was turning off the charge, did something happen at that moment that blew the buck converter? I don't know. But as of right now, it looks like about 100 watts extra was burned over 3 weeks with the setting set to 3.4. Okay, turning off battery E. Okay, it's off. I'm going to try the cable from what was battery E on battery D and see if it still works. The button, that is. Yeah, the button works. I don't know why that wasn't coming up earlier. Obviously something happened to it when it was shocked. Okay, reset history. Yep. So there's battery D. It's showing 215.6. This is the one we set to 3.3 volts. That's still plugged in. I expect this is still running, but let's see if those wires jump. No jump. And the charge is ramping up. All right, let's see how long this one takes. Oh, still charging. I thought it had just finished charging. I saw the grid power drop for a minute, but it's still pulling 2 kilowatts. Wait, the batteries? Oh no, it just dropped off again. Is it full? Yep, it's full. Okay, so this is battery D, which was 3.3 volts. Hey, tatters. Oh. And it's showing 0.3 kilowatts to charge it up. Considering what happened to that one, I'm going to say it was 0.3 kilowatts, which would make all three of these 0.3 kilowatts. It probably got an extra 100 watts in there after everything that happened and I recharged it. So far, 3.3, 3.4, and off need 300 watts, give or take, to charge back up over 3 weeks. Statistically insignificant. All right, tatters, I want you to stay away from here, buddy. No, that's the opposite of staying away from here, buddy. Oh, come here, buddy. I'm kind of nervous about all this stuff around here. All right, let's turn off battery D. Battery D is fully off. Battery C was 3.2 volts. What is the average deviation on those cells? I'll see that in the editing, but I don't know what it is now. I should have checked to see what the average cell voltage was, because that would have been really useful to know if it was trying to balance. Oh, tatters. Average cell voltage is 3.3. This is C is 3.2. So this one should have been balancing more. Is it balancing? Current balance is 0.000. It's not balancing. Okay, it would help if I could type this. Tatters, you are being so adorbs. You know that? Okay, balance is enabled, but is it actually balancing? Balance current is 0.00 amps. Oh, the balance current is 0.0. Battery C is showing a remaining capacity of 204 amps, claiming it burned 80 amp hours in the 3 weeks that it was off, and that it's at a 73% state of charge. Excuse me if I seem a little skeptical. Words. Excuse me if I seem a little skeptical. Let's turn this on. It's ramping up. 30 amps. Oh shit, stop! I forgot to reset the... See, if I was a professional YouTuber, I would have had this all checklisted out. I need to reset the history on this merchant. Reset history? Yes, reset history. Now turn it on. Okay, so now it's charging. This is the one where I would expect to start to see a higher parasitic draw. I really expect to see it on 3.0 and 3.1. 3.0 being how the BMS shipped. 3.1 being well below. Now, okay, so here is a thought while I wait for this to charge. What triggered all of this was how much power had been consumed before I did the main discharge test. Were the batteries truly balanced at that point? I mean, they should have been, because we did that big parallel bank top balance. They should have been completely perfectly equal. So part of me is thinking, did it consume more power before? Because it wasn't actually, like it was still absorbing or whatever you'd want to, is it absorbing? I don't know what it would be, settling. And the period of time I had it on plugged in and charged up before I started the discharge test, it was actually balancing more because it was still trying to get just that top little bit perfect. And then it just didn't need to balance this time. I don't know. If I don't see a big difference in the bottom and packs, that's going to be what I'm thinking. If I see a big difference, nope, it was trying to balance when it shouldn't have. Might as well leave the camera running. I don't know if I got it on video, so in case not, I was trying to look for cutters to cut that line because I didn't have a fuse in it, so I had no way of breaking it. I tried using a drywall knife because that was close at hand because I was doing drywall work. I couldn't find cutters anywhere, and I went over to my workbench to try to find some cutters. I'd taken everything upstairs because I'm working on the 12-volt batteries up there, and the only thing I could find was a chisel. The hammer was already here because I was using it for the drywall knife. So I grabbed the chisel, stuck it on the floor, and schmucked it. I hope that came through earlier. Maybe I'll include this even if it did. Desperate times, desperate measures. Note that when I did this, I was conscious to only cut the positive line. I wasn't trying to cut both because, as I think I mentioned in a previous video, if you cut both lines, you create a dead short and you're back to square one. Doing it this way, just cutting the positive, there was no possibility of a short. And indeed, as soon as I cleavered the wire, the sparking stopped. The fire didn't, but the sparking did. FML. Hey, buddy. Mr. Tatters always knows when I'm stressed out. Don't you, buddy? My old friend. Still putting 1700 watts into the battery pack. 0.3 kilowatts. Disconnected. The remaining capacity was really far off. The smart shunt again is saying 0.3 kilowatt hours. And that was battery C at 3.2 volts balance current. Not quite sure what to make of that. I would have expected to be seeing a difference by now. Is it charging again? It is. And now it's saying the remaining capacity is 277.2. Huh. I think my approach might have been slightly flawed in that I was stopping as soon as it disconnected after the first cell, thinking that was charged because the cells should be balanced. But they should be balanced. I'm very rapidly losing confidence in my methodology here. Should I have allowed it to just continue charging for a while instead of stopping it as soon as it goes into cell overvoltage? So one of the problems with this test is that I didn't do a proper discharge. I wasn't leaving these low while the batteries were actually being drained. I'm wondering for this test to be proper if I need to continue to drain them, let them fall out, let the voltage drop, then, like say I get to 50%, like total pack, 50% state of charge, then recharge it and see if I could see a difference. That'd be closer to real world. Damn, I'm doing all this video and I don't even know if there's any use to it now. Well, it's still 300 watts. If there's a big cell deviation where the balancing would normally need to run more often, you could argue that's more of an issue with the individual cells and not the BMS, which is strictly what we're trying to test. The average cell voltage is 3.53, and we cut off at 3.6. So if I was to do this test again, and I don't think I'm going to do it anytime soon, I think what I would have to do is charge until I hit a defined, consistent delta cell voltage. You know, say 0.005 or something like that. But I think there's still value in this test in that I'm still at least seeing patterns. Maybe I'm just trying to talk myself into finding value in this. I don't know. It's still 0.3. All right, turning off cell C. Pack C is totally off. I keep forgetting there's no screens there anymore, so there's not really anything to look at. Reset the history. Let's turn on battery B. Battery B was with a balance current of 3.1. I'm guessing if I didn't see much of a difference on battery C, I honestly don't think I'm going to see much of a difference on B or A. But let's finish this to find out. It's saying 204 amp hours remaining capacity, which is going to be not even close to right. The delta is 0.003. Remaining capacity is, average cell voltage is 3.3. So it would have been balancing along here, but it's not balancing because the delta voltage is too low. Here we go. Battery B's charging. Be back after these messages. Oh, right, I don't have any sponsors. Be back in a second. All right, battery B, it stopped charging. It took about the same amount of time as the rest. 0.3 kilowatt hour. Yeah, same as before. After 3 weeks, with the balance current set to 3.1 volts, I am seeing no appreciable difference. This is not the result I was expecting. I'll do the last one, battery A, which was set to 3.0, which was the default, but I honestly expect no difference. It's going to be 300 watts again, I am sure. Turning it off, and where's the power switch? Battery B is off, let's turn on battery A. Go into the smart shunt, reset the history. Connect to battery A. Oh, there it is, 204. So it's, I don't know where it's getting that remaining capacity number from. That's clearly full of shit. Turning it on. There it goes. I'll be back in a minute. I'm sure this is going to be 300 watt hours again. The last battery is at 0.2 kilowatt hours. I expect I'm going to hear the fans in that thing spin down in about a moment. Let's see. Remaining capacity, 207.2 amp hours. That's going to jump in a second. It is balancing, which makes sense. 0.3. Is this one actually going to be higher? 3.6. Okay, should disconnect here in just a sec. There it goes. Just disconnected. 0.3 kilowatt hours. So, at least initially, it looks like for 3 weeks with no loads, that last part potentially being very key, for 3 weeks with no loads, the voltage where balancing kicks in made no effective difference. So while I've been waiting for this to charge, I was trying to think of what I could do next. So what I'm going to do is reset the history again, and now I'm going to bring all of the batteries back online and just let it sit and absorb, it goes into the high voltage, does the balancing, disconnects. And let's see what it takes now to bring it rest of the way up, if that makes any sense. Okay, turning on battery B, turning on battery C, turning on battery D, turning on battery E if it wants to play nice. Yep, it's fine now. And battery D. So all the batteries are on. Connecting battery B, C, D, E, F. I don't know why I said that so loudly. F. So now it's pulling 2 kilowatts, pushing in 1700 watts. But now it's across all the batteries. So as an example, oh, interesting. Battery A is losing 10 amps. That's probably just because these ones have settled. This is where the screens were really nice because I could just look and instantly see what all the batteries were doing. I'm going to be bitter about that for just a wee little bit. Please bear with me. I'll get over it. It is now midnight, 6 minutes after. I'm probably going to leave this for about an hour. I've got to go and do my end of day stuff anyway. I'll see how much more energy is absorbed over the next hour. Back in a bit. So before I get started, I wanted to mention that I said I was going to leave this for an hour and see how much power was further taken up by the batteries. I ended up leaving it overnight. It's been 20 hours maybe, and it has pulled 600 watts, 600 watt hours. It'd be about 100 watt hours of battery. So if I added that to it, all the batteries took about 400 watt hours over 3 weeks. That's not very much. That's a little over 100 watt hours of parasitic draw per week per pack, despite the fact that the balanced current trigger voltage was quite different. It could be that the batteries were so balanced that the delta was too low to trigger the balancing starting regardless of the trigger voltage. If that was the case, when I went to charge this up, and I was surprised at how much power it took before I could do the main discharge test, it should have been the same there because all of the cells were parallel balanced. They were exactly the same voltage, so the deltas would have been really low there. I'm kind of starting to think now that a lot of the parasitic draw that we saw might have been coming from the screens, because the one thing that was different with this test, think whatever deity you believe in, I didn't have the screens on while I was away on vacation. These were connected, and, well, it's not wired anymore because I cut it with a chisel, but these were left connected all the time. So even though the screens were unplugged from the output side, the input side was still charged. So maybe this was part of the draw, but again, this was there before the first test. So really the only real difference was the fact that in the week before I started the discharge test where we saw the huge internal parasitic draw, I have to think it was those screens. It's the only thing that makes sense. When I set out to make this video before Christmas, I expected to have a very different conclusion than what you're seeing here. But in science, a null hypothesis is still valid. So though this is not what I expected, it's interesting. It's interesting mostly because I don't know what's going on. Anyway, one of the things I like about this channel is how you guys have a lot of insights that don't cross my mind. So this is going to be a particular one where I'm going to be really curious to hear what you guys have to say in the comments. I've learned a lot from y'all. Now, before, let's see if I can get you to see this. This is black, so it's going to be hard to see. I don't know if you can see, oh, I think that's a good view right there. You can see there's a hole blown out of the back of the buck converter. The way that the plastic is bent, it makes me think that this built up pressure and exploded. The spray of sparks that I was seeing, I originally thought that the diode had failed because it is blackened. But now what I'm thinking is the back here is what ruptured and threw flames out this way. I think all of the black I'm seeing around here is scorching from the actual flame. I don't think the diode failed. I think this unit itself actually failed. Now, right after this blew up and I put the fire out, I took a 1 minute cell phone video and I uploaded it. I've already taken it down. I don't know why I shared it, but I shared it rather than waiting for it to be here. In that time that it was up, I had a kind of unfortunate number of people who say, oh, well, it must have blown up because you bought cheap shit from China. This is a CUI buck converter that I bought from Mauser, which anybody who's in the tech or electronics industry will know is a very reputable seller of components. And it wasn't a marketplace, it came directly from them. And the company that actually makes this is CUI, which is an American company. I can understand the urge to want to immediately jump and say, oh, it failed because you bought cheap shit from China. But if I could ask, please don't do that, especially when you don't actually know where the parts came from. It doesn't sound good. It's not the kind of vibe I want in our community. If this had actually been a cheap part I bought off AliExpress from China, from a no-name or questionable reputation company, and there's something specific you can point to, then call a spade a spade. But when you don't know where it came from, jumping to assumptions just kind of, you know. So in any case, I don't know what happened here. I'm pretty sure that it blew up when the BMS cut off the charging current, when one of the cells hit maximum voltage and it triggered a disconnect. At that point, it was pulling 30 amps in. And it was at that moment, I believe, I wasn't here to confirm this, but considering 300 watt hours had gone into the pack, which matched all the others, that was the moment I heard the pop. I'm guessing it has something to do with the current that was flowing into the battery at the moment that the BMS cut off the charging current. Something happened, there was a jump or something caused something in here to fault out. I am not an electrical engineer at all. I think that's pretty obvious by this point. But so Andrew, who you've seen help me with the design of this, he's the one who helped me sort out how to get the server power supply working so I could power the iCharger. He is a professional. Actually, the beginning of the last video was in his lab. He has asked me to send him the carcass, and I'm going to do that, and I'm going to send him a couple of the working ones. He wants to do a post-event analysis to try to figure out how this thing actually failed. Like me, he's quite shocked that these failed, considering this is relatively good stuff. It's possible that I did something, I overheated it when I was soldering it. I mean, you saw in the video, I'm not a great solderer. It's entirely possible I overheated something and caused a melt of something inside. So I'm not blaming CUI at this point. It very likely could be me. Or it could just be one of these things where, you know, you make a million of something and stats says a couple of them are going to be bad. Maybe I just drew the short stick. In any case, this will be analyzed, and at some point in the future, I'll hopefully have an update as to what happened. In the meantime, I run without screens anymore. That's it for this video. That's also it for this build series, at least for now. The time limit I have to get the boat ready to bring it home, a 660 nautical mile journey, is fast approaching me. So a lot of my focus is now going to be shifting, and so the content of the videos is going to be shifting towards getting the boat ready to bring it home and then actually bringing it home. The first step of that is I need to build a couple of 12-volt batteries, which I have already started upstairs. That's why I didn't have my cutters to cut the wire when things went bad, because I got them upstairs. Anyway, that's what's coming up next is the 12-volt build, and then there's going to be boat work. So those of you who are here for the boat content and have been very patiently waiting, it's coming soon. Those of you who are here for the battery content, I will soon disappoint you. Anyways, I'm the Digital Mermaid. I'll see you guys next time.